Used to eat those gummies when I was younger. Those Flintstone vitamins.
Oh yeah, man.
Those are
I
good. Those are classics, man.
well. Let me put it this way. So when I was a little tyke, we had Flintstone vitamins when I was a kid.
Hmm.
Put just to put that into like,
Holy
holy
crap!
crap. Yeah, we're going back 50 years, right? Meaning I'm older than 50. But I remember that we were super poor, like really really crazy poor, and my little brother had like a health thing where he had like surgery as a baby or something back in the 60s. Anyway, so he was the fragile one, right? So he got Flintstone vitamins.
Oh, really?
And none of us, the other ones that, I mean, he was the one that almost died. So for my mom, that meant he was the heir to all of the Flintstone vitamins. We couldn't afford Flintstone vitamins for all five kids. So only he got the Flintstone vitamins, which means he's probably the one most protected right now from COVID by, just by virtue of his robust immune system or whatever. Okay, let me see. Other than that very last part, the rest of that is actually true. About only Wes got the only Wes
Is that
got
your
the
brother?
Flintstone vitamins. I don't even know if he remembers. I gotta ping him. I'm gonna ping him and find and see if he remembers being the only one with the Flintstone vitamins.
Yeah, that'll bring up a lot of good memories if you asked him about it.
Yeah, and then I know we gave them to our kids.
Then just relate it to now, and then have him and you also buy Flintstones vitamins for all your kids, and he can buy them for his kids if they're still available. That is
They're still around, right? By the way, we're talking,
something.
and unless some of you are like, get on with it, I'm dropping the lectures into the
I like the
slides as
vitamins
always.
thing. Let's keep up with. No, I'm just kidding.
Keep the vitamin theme going.
No, we can continue.
Yeah,
I'm
no,
holding.
I'm burning time in part because I'm not like killing time. I'm just notice I dropped a link into Discord for the lecture that's streaming right now. I'm putting lectures in scare quotes for now because it'll become a real lecture like real soon. Okay, and now that is also saved away into the class schedule. Okay, and just as a reminder to everybody, reminder time. You can't. The point. I'm not going to blow this up because it doesn't really much matter. But notice right here. Okay, I lied. I will blow it up. But all of the lectures, there's links to every lecture from the day on which it was given, including today, which I just added. Okay? Everybody
I have a
cool?
question. I have a
Yeah.
question real quick.
Oh, let me
Um,
turn my Mozart down here. I've been
oh,
just kind of let
yeah.
that roll for a while. Hey, yeah, what's the question?
So since we're a bit late, kind of behind in the lectures, does that mean that you're going to push some of the due dates out for the later assignments, or will they all still be due on December
Oh,
10th?
that's a really good question because we are, I said before that it does kind of like, compress down the stretch.
Mm-hmm. Because they get
Uh,
shorter. Yeah, they get
they get
smaller.
shorter, they get smaller. Right, right, right. But what you're saying is really right on.
I
Yeah.
mean, I'm fine either way, but I mean,
No,
just
it's
to know for like my own sake, I guess, and for the sake of everybody else.
yeah. No, I think it's a totally reasonable question. I really do. And so just looking at the schedule, and I guess what's the last day of the official last day of the semester is like the 11th, I think, or is it the 10th? It might be the 10th. No, we got to do something. We got to do something down the stretch to give a little more latitude to, you know what I mean, to work through it. And I thought about
Okay.
that. I also thought about another angle was like speeding up just a little, not speeding up, doing like, hey, this weekend let's do, the December 8 lecture, and then like Tuesday we do the December 10 lecture. So there's at least they're available. Well, the other thing is that actually all of these lectures, all this material is actually already on my YouTube channel from spring semester when we were teaching these same slides. So that actually, let me just go with, let's stay with the schedule as far as, I'm not talking about due dates, talking about the lecture. We'll stay with the lecture schedule. So I'm rejecting my own idea, but I didn't know it was dumb until I said it. And, but if anybody is like chomping at the bit a little bit, like, I got to do, come on, I'm trying to get to the stack. If you want to see those lectures, you can just go to my YouTube channel and just look for end of the spring term when I was teaching the same stuff. Also streaming. And I don't think I had memes at the time. I think maybe I did. I don't think so though. We were still adjusting to the online world, after spring break. Okay, so you can go if you're chomping at the bit to jump ahead, then go to my YouTube channel and you can find these lectures from out there, and the assignments themselves, the homeworks are posted. But to what Ison was saying, I think we've got to build in some latitude for at least the stack, because we usually go, it's due a week later kind of thing. You know what I mean? And we're going to talk about, we'll have to build in some extra time for module 11 and 12. We have to.
Are the exams for module 11 and 12 like shorter?
Mm-hmm.
Is the homework shorter than the other ones? Okay.
Yep. In fact, if you go, you can't see these, but I think it's literally something like these turn into like 20 points each. It's a really imprecise metric, right? But like some of the early exams are like 60 points, 80, because there's so many little pieces, right? Like it's the binary arithmetic and individual little chunks. Now it's kind of like write some code, do a thing, and it's the concept. There just aren't as many concepts, so it just gets a lot shorter. And that's why. And I've had the question asked, and I've answered it before, but I want to reiterate. When I compute the grades, the question is, okay, is it like the aggregate grand total of all the points across, in which case the early modules are worth more because some of those are, I'm going to hide this over here because we'll enter FERPA violation mode otherwise. But, I'm just pulling up the grade units. But like the module exam scores, like, module 1 is 18 points, module 2 is 30, module 3 is 47, module 4 is 44, right? That's getting into a lot of that mathy stuff. Then it goes 21, 24, 26, 20, 24, 12. Module 11 is 12, and then 22. So they just get, small, it's like most of the smallest ones are down the stretch. Unlike, right? So when I do the grades, I actually calculate your grade two different ways. One is I take the aggregate of all the points. So if you crashed and burned on a small one, but you smoked a big one, right, that would be beneficial to you. The other approach I do is I take all 12 modules and I treat them equally. Right, as if they were, 8-ish% each or something like that, and look at it that way. And then I literally have my own spreadsheet. I calculate it both ways, and then I give you whichever grade is higher. I give you whichever percentage is higher, okay? And then so some of the grades that show up in that last, percentage of overall percentage in the class, came from the even approach, and some of them came from the aggregate approach, and it doesn't matter. You get whatever your best point total is. Okay. Anyway, I think that's totally fair, and because I really, when it was all done, and I did a little bit of analysis on it, and I discovered that literally some students were better, benefited by the one approach, and other students were benefited by the other approach, and I couldn't find a principally based reason to favor one or the other. You know what I mean? So no matter which one I picked, it was going to hurt some students and help others. And then I flipped the other way, and then the help hurt got flipped. So I'm just like, well, let's optimize to help everybody to the extent possible. The other thing that I do when it's time to calculate grades, there's always a little bit of curving, in the sense that if there's like a big bunch up around 90, there's a bunch like, if there's somebody at like 90.5, 90.4, 3, 2, 1, 90, 89.9, 89.8, 89.7, and then there's a break. I'll take the ones that are, if I can't see a clear distinction, you know what I mean? Like, oh, this student was actually different, in performance from that student. If I can't see that, then I'll just bunch it and just scoochy them up and, push those into the A minuses, for example. Okay. And then the other thing I'm looking for is sort of just, if there's any kind of tiebreaker moments where I want to try to give some extra advantage, I'll usually favor those that have, taken advantage of retakes. Like if somebody's sitting on, whatever, 79%, which is a C plus, and I look and they've never taken the retakes are available to everybody, always available, and they've never done a retake, never taken that effort to bump up their grade, in other words, then I'm like, no, that's, but if I can see that there's been a lot of effort, sincerity in that effort, then I can kind of scoochy just a little bit, it's not going to make or break the big difference, it's not going to propel you into a different category, but I hope that makes sense. The core philosophy for me from a grading perspective is, I usually put it this way: I am not willing to care more about your grade than you appear to. Okay? So for example, this has happened to me. Student comes to me in mid-November. Haven't seen him since late August. They haven't done anything, right? No contribution. Comes to me and says, what could I do to pass this class? What's my answer? I don't want to be unkind, and I'm not going to be mean or snarky, but the answer should be pretty obvious. Right? The answer is nothing. There is nothing you can do at this point. I mean, in this class, that's not entirely true. In this class, if you already really know all the material, you can like submit all the module homeworks and take all the module exams. That's what, you could do that. But you know what I'm trying to say? If there's like classes with deadlines and things like that, it's like, you got the idea. The other thing, just to clarify, we go into finals week. Finals week just basically continues the testing lobby. There's no comprehensive final in this class. But the final project is due on the last day of the semester. Okay, and you have had all the tools you need to do that for a while now, at least for a week or two, or at least from around before Thanksgiving. But that one is due on the last day of the semester, which I think is either the 10th or the 11th. And if you have special circumstances, things come up, whatever, then, please let me know. Stuff happens in life, whatever, right? Your wife has a baby, you have a baby, whatever. Your roommate has a baby and it just disrupts you. I don't know, right? Maybe there's no baby involved, but there's something else. All right? Everybody got that? So, I think you know me by now. I'm going to work with you and be in every way to be fair, and where you're putting the effort in and being sincere and striving, I'm going to match that, with as much leniency as I can give without compromising your learning experience. Because that's ultimately what I'm here for, is to help you with that experience. Cool. Everybody golden? A couple comments coming.
Sounds good.
What's that?
Sounds good.
Awesome. Okay, thanks, Stephanie. Are there any other Yeah. So Bradford, yeah, I guess I didn't really double back to that. So for 11 and 12, yeah, let's. I'm willing to take 11 and 12, just like at any time. I mean, obviously, you got to submit the homework, and then you got to leave yourself enough time to take the exam, right? But the testing lobby just extends into finals week, right? So your own, it's okay. One last thing. I know I'm burning time here, but this is important. One of the things that there's kind of a university guideline. This is very common, by the way, at universities, which is to not have assignments due during finals week. That's kind of a normal thing. Now, the reason that they do that is one that I happen to agree with. The reason they do that is, look, you've got these comprehensive finals, right? And you've got it. So over here on this schedule, and then if the teacher's like, oh, you've also got to be writing some big paper. Now there is an angle that says, that's the comprehensive or that's the final. That I think is reasonably fair, and you get to budget your time to pull that off. But what you don't want to do is have a bunch of crap due, and then you're taking away from what ought to be a focus. So in my mind, every class, the teacher kind of decides what's that focus, right, for finals week. Could be a comprehensive final, it could be a paper, it could be, right, but in my mind, it needs to be kind of one thing. And if it's not a comprehensive final, it maybe could be a different thing. But if there, I don't believe, based on university policy, that it's super cool to have both a comprehensive final and other stuff also due, because you think you're doing a favor for the students, but you just put pressure on them, while you're trying to prep for other stuff. And it really does, in general, I think, create a bit of a negative effect. Having said all that, in this class, it's the module exams, right? And so the final, maybe you want to retake number 3, number 7, and you need to take number 12. Maybe that's what okay, then for you, that's your final, right? It's like individual finals. Then that effectively becomes your final, okay? Yeah, and so Morgan, no, the final project, not okay to push back since it's not like your final. So that bad boy needs to be wrapped up, because the testing lobby, the module exams, either taking them, originally in the first place, if you haven't taken any, again, you've got, during finals week, you've got one take, you know what I mean? One last take at any module exam, but the project does need to be wrapped up, okay? And I want to just do a quick double check, just to check myself, before I wreck myself. I need to check real quick about what I'm saying in the syllabus. Yeah, okay. Let me just put this over here as well. Again, I know that we need to get onto IO, but this is also, we're only a week away from done. Okay, so here we go. Large program. One significant programming project that's due on the last day of the semester, and it's a decently sized problem. When you do it, by the way, there is partial credit. I do give partial credit. If you get a chunk of it running, little bits. So yeah, Jacob, if December 18 is that the last day of finals? Whatever the last day of finals is, actually, hang on. Do I put finals week in here? I know it's over here in the class schedule. Final exam. I don't have the dates on the finals, but yeah, if that's the 18th? Yeah, whenever the last day of finals is, that's the last day to take module exams. Midnight on the last day. And again, you get to do it on your own schedule. But okay, let me come back to right here. When we have done this thing, yeah, Morgan, you'll get like less than 5 points for displaying to the monitor, please type an instruction. But you're on the right, you're kind of like in the right spirit of it. If you can do a couple of instructions. It's not the majority, but at least kind of gets you started, right? That's good. I mean, and therefore, I want to reward anything that manifests, an understanding of things. The decently sized problem, you already know what that is. We've talked about it. But this is really important, and I'm going to give you real quick again the fear speech. Do not, please, for the love of all we hold sacred, please do not cheat on this project, or you will fail the class and be reported to the university, whatever their kind of honors. I don't even know what we call that place, but you know what I'm talking about. Don't do it. Don't do it. Don't resubmit your roommates that he submitted, 2 semesters ago. I have them all. I review them all, and I can tell if you've borrowed one from somebody else who's taken this class. I can also tell if you've borrowed one from some cheat site or some other rando place, okay? So if you really can't do it, do the best you can. Stop, take your lumps, take the hit, and if you need to come back and do it again next semester. But really, for the love of God, please don't compromise this one, because I will track it down. I will find you. Cue the chosen. Sorry, the taken. Cue the taken memes. But right, and so this is it right here, right? If you cheat, this is me screaming at you. Please save yourself, etc. But do come talk to me in the TAs. We're happy to look at your code and go, here's what I think you're misunderstanding, or no, that's actually great, or whatever. We are very happy to look at your code and try to lend a bit of a hand, right? We're not going to write it for you, of course. Okay. Oh, and usually it winds up being, if you consider the number of instructions without looking at comments or data, it's usually around 500 instructions. That's kind of a general size. And it usually takes between 5 and 10 hours to do. For those that are successful doing it, you can, if you're not going to be successful doing it, it will take you an infinite amount of time, right? You have to come to a closure before it's the halting problem in this sense. You have to finish to know how long it took you. Otherwise, the clock's still running. But, when I first did it myself, I've done it actually a couple different times, different ways. The first time I coded it myself, it took me 6 hours in one crazy all-night binge. Literally, I started it at 1 a.m. and at 7 a.m. I was done. And I was probably over-architecting it, you know what I mean? And over-testing it, maybe that's not true. But I'm just saying, there are students that have done it quicker than I did it the first time. But I wasn't trying to optimize for speed. I was also doing what I do when I write code, which is I take it very slowly and I double check. I'm testing it every step of the way to know that it works properly. Okay. Cool. Okay, that is all the public service announcements. Took a little while, but we needed to hit those, okay? We did need it. By we, I mean you. I'm fine without it. Okay. All right. Are we ready for finishing I/O? You ready for the good stuff? You're like, yeah, man, been ready for half an hour. Why don't you shut up and give us some I/O? Come on, circus boy, dance. Okay, I'm going. We good? We're all good, I presume? Bring it. Yeah, okay, awesome. Thanks, David. Yeah, bring it on. Yeah, that's actually about one of my favorites from a very underappreciated animated film. Okay. When last we met, we were talking about Gary Goldman, highly recommended, Dr. K approved comedian, Gary Goldman. Dr. K approves of this message. And we were talking about communication, and we're talking about synchronous versus asynchronous. Remember that? And so here's the deal. When we communicate with each other, when humans, not even humans, when any animals communicate, there is protocol. Okay. Now we sometimes think of the word protocol as like, there's a certain protocol when you meet the queen. There's a certain protocol. There was some movie, I can't even remember, but it was somebody meeting the queen, and there was all these instructions about how you have to bow and how long you have to stay bowed and how you have to enter the room and leave the room. And I can't remember which movie it was, but anyway, some film. We think of that as protocol, right? Like, what's the protocol? For another example, if anybody has ever spent any time in Asia or been back to Asia, in particular Japan, on a business trip, I don't even have one, but business cards, there's a ritual, and I don't know if that's changed. It's been 20 years since I was on a business trip to Japan. But imagine that this was my business card. There is a process where you hold the business card in two hands, you present it, right? It's very respectful, and then the other person receives it with their two hands, and then they look at it and they have to like admire it, and then you have to thank, and there's it's kind of cool. It's obviously super traditional. And again, I don't know if that's still. I haven't had a business trip to Japan for 20 years, but I was there a number of times in the 90s, and that was the thing, right? That's protocol. And whereas in America, for example, back when business cards were a thing, they're really not a thing anymore. I mean, more and more and more, you pop out, hey, here's my card, and you're like, okay, I guess why don't you just add me on LinkedIn, connect with me on LinkedIn, and I'll just be able to track you down. Or why don't you just shoot me your contact? Or, you know what I mean? Like this, I got to scan, I got to enter it. It's very old school. So I haven't had a business card. I don't even think I have UVU business cards. Maybe I do. They probably made some for me, whether I wanted them or not or something. I don't even know. But my point is that these are protocols in America, and the Japanese used to give us a hard time about the fact that when you come to America, it's like Texas Hold'em. Everyone just deals their business cards out on the table. Everyone meets in the conference room back when that was the thing. They just start deal them, and you're like, oh, thanks, and you set them there, whatever. There's no ritual, right? Okay. The protocol exists for a number of reasons. They grow out of history, right? There's history behind why we shake hands back when that was the thing. I wonder if that's going to change post-COVID. I think there'll be a lot less handshaking post-COVID, sure. And again, Japan, the bow, man, that's a sanitary. The bow is way. That's a safer play than let's rub our skin together. And and where you've been like picking your teeth or whatever, or worse, Anyway, protocol. So when you do the protocol, the reason you're doing it is because you're trying to set up the rules for communication. Okay. In the case of, hang on a second. In the case of business or interactions or whatever, the protocol establishes a bunch of rules, and when you get into data communications, basically, there's also protocols, and we literally call it handshaking, right? And what I'm trying to help you to understand, and this is one of the cool things about CS, is that everything in CS at some level is kind of a metaphor for life, right? It comes from life, or it models life, or it emulates, life in some way, simulates it, or it interacts with it. So again, in real life, just understand you're like, hey, how you doing? And you're like, I'm great. And then, but if you're just like, hey, hey, how you doing? Why'd you steal my backpack? You broke the protocol because you're supposed to acknowledge the, hey, how you doing? And you have to say, fine. They don't actually want to know how you're doing. You don't want to tell them about your recent surgery unless they ask about your surgery. But how are you doing? The answer needs to be fine, pretty much. That's the protocol. And it helps us kind of know whether you're crazy. And if you come back at me when it's like, okay, you don't have the protocol down. Maybe you're an axe murderer. I don't know what you are, right? But the protocol helps with all that. With data communications, there's a similar thing that happens where you're doing things like, let's take wireless data communications. Take Bluetooth, okay, or Wi-Fi, or infrared, or protocols like that, ERTA. There's a process where you start with discovery. You find out kind of like who's out there. Wired protocols, you're already plugged in, and the assumption is that your signal is going to go out on the wire, and that everybody who can see it is going to see it if they want to. But with wireless, you don't have this. So wireless has a device discovery phase, okay, that you go through in wireless, right? That's part of the handshaking. Who's even out here? Where are the access points if I'm trying to find a Wi-Fi, right? I go to this channel, I ping anybody, okay, I got the list of who responded, right? Go to this channel, I ping anybody responding. Now I get a list of Wi-Fi access points, and then I present those to the user who gets to pick which one, right? Then I can go, and then they can say, oh, I need a password. That's all handshaking and part of the protocol. Once you've established a connection, meaning that I know who you are and I know how to refer to you, I know how to get to you, right? Then there have to be protocols that say, okay, when I have data for you, I have to send you this kind of packet. The packet announces to you that what's coming next is data. Then you can acknowledge that. Then I'm free to send the data. And I'm like, and I can say, here's some data, I'm not done. Here's some more data, I'm not done. Here's some more data, I'm done. Then the other side can acknowledge and say, whatever. All of that elaborate stuff is what we mean when we say protocols in data communications, okay? And the establishment of that connection is loosely what we refer to as handshaking, all right? Kind of cool, right? And this is like your 4-minute intro to data communications and networking, which is a very cool thing to know a bunch of things about. So this idea of communication protocols, making sense out of the asynchronous nature of data transfer, right? Where we talked about that, right? That it really is kind of like a lot of async. I'm going to give you a packet. You could sit on that packet for several minutes before you show it to somebody or do something with it. But you have to acknowledge it. It's a way of trying to creating an experience out of asynchronous chunks. Okay? That's the idea. Now, it turns out, before I get to the ready bit, it turns out that in more complex systems, Ethernet, Wi-Fi, which is actually just a variant, really, Bluetooth, ERTA, RFID, any of the near field communication. I feel like I'm missing whatever. Zigbee. There's a bunch, right, of these different kind of protocols. Well, what maybe we don't think about is, even if you think about that, do you think about the fact that this, which is my wireless keyboard, that keyboard is also, hang on a second, that's part of I/O devices. The keyboard's part of the deal, the monitor, the screen. I've got to somehow send stuff to that. There is data communication. Now, there's no wire here because that's Bluetooth, but the traditional keyboard, which I don't even know that I possess one, but the traditional keyboard, right, it has a cable. What's going through the cable? Electrons. And it plugs in so you can send signals. And basically, there are formats and there are protocols for how you communicate to read from a keyboard or to write to a console or a display. Okay? Does that make sense? Is that kind of cool? Is that at all revelatory for anybody? Hopefully. Can everybody still hear me? But no comments or chat comments for a while, so I want to make sure we're still. This is also.
We're still good.
I heard
Yeah,
the bring. And by the way, that's actually a protocol. There's a comparable thing when we do a ping in Ethernet in TCP/IP. I mean, that ping is basically, it's a little bit like, are you still alive? So that's actually cool. Hold on, sound. Oh yeah. Yeah, that's also my way of just making sure we're still connected. That's also, I'm not just talking about, right? You ever do the lengthy speech to somebody who dropped off the call like 5 minutes ago and you're just going?
Oh, that's the worst. That is the worst.
Yeah.
Like,
what
oh,
was
sorry, I accidentally picked up on the last thing that I heard was this a long time ago, and you're like,
Yeah,
oh, my
exactly.
goodness.
That's right. The last thing you said was, I know this is a bit of a long story, but, and then you cut out. Yeah, right. But that's all protocol. That's all. Even the can you hear me now? Can you hear me? Can you hear me now? Yeah. Wait. No. Yeah. Okay. Good. It's reestablishing connection when you're coming through, an inexplicable dead spot on I-15. Why should there be dead spots on I-15? I don't know. Were you shocked by traffic there, people? No. It's an inadequacy in the infrastructure. But anyway, okay. So the question now becomes, how do we do? We only have 2 I/O devices in the LC3. We have the keyboard and we have the console, the display, if you will. Okay, that's it. So, how do you do it? Well, what we normally do with certain kinds of I/O, like this kind of sort of device communication, is we have a ready bit. It's remember the NZP bits, the control, we call them control codes. They're just like 1-bit registers, right? Well, we need something like that, those control codes were basically just 1-bit registers that communicated information that was useful to us. Well, we need something like that, but what we really need, and the reason we call it a ready bit, those were called NZP bits because they were like, well, what was the last value written to a register? It was negative. Okay, N bit is set, and I can derive meaning from that. Well, the ready bit is similar in the sense that it's just a bit somewhere that I can just read, look at, examine. And if it's on, then it's like I'm good for whatever. So if I'm writing to the console, the ready bit would say, yes, you can give me your next ASCII character. And if it's like, nope, this is my impersonation of a ready bit, off. It's like, nope, then it's like, okay, how about now? No, okay, how about now? Nope, okay, how about now? Yeah, okay, boom, here's my character. And then he takes the character, turns it off, and starts processing to get that thing to show up on the console. When he's ready to receive, boom, it goes back up again. Okay? Same thing when you type on the keyboard, right? I go to read from the keyboard and I look at the ready bit. I'm like, and all the ready bit in that instance says to me is, do you have something for me? Nope. I check it. You got something? Nope. Got something? Nope. Something? Nope. And then the user presses a key. I have the ASCII value and I set the ready bit. Then you're like, how about now? Yes, okay, give me the character, and then it clears it, waiting for the next keystroke. And then, of course, all that can, in practice, happen pretty fast, right? But that exchange of checking the ready bit to know if I'm okay. That's also, do you see the asynchronousness there? Asynchronousness. The asynchronicity, I'm not sure what the right way to say that is, but the asynchronous, you see the asynchronous nature of that exchange, right? It looks like I'm just typing and you're just reading, and like that feels kind of synchronous, right? I'm typing and it's appearing. And from a user experience, it is. Down underneath, it's not. It's async. I'm sitting there with a bunch of wait states. And then when I finally get the character, I go like that. But the keyboard just like waits, until the code comes and grabs it, and then it clears it. So it's a way of sort of interacting and making that, bringing a more of a synchronous experience. Okay. As this is a term that's not going to show up on an exam, but I wanted to just introduce you to the term semaphore. Okay. It is a term that shows up in operating systems, especially really operating systems, when you're trying to get into code that you don't want to separate. There's some things that have to happen, and they have to happen together. And if you separate those activities, so you set a semaphore, and the word semaphore, anybody Italian, Spanish, I don't know. There's got to be something similar in Portuguese, but I don't know what it is. I could look it up. And I don't even know what it is in French, and that's absurd because I speak French, but I'm not like I know every word in French. I don't know every word in English. Spanish or Italian, is there a word that reminds you of semaphore? I'll tell you what it is in Italian. It's semaforo. Semaforo. That looks like semaphore. There's got to be something similar in Spanish, right? Anybody? There's got to. Come on, I know there's some Spanish speakers. I speak Spanish, but badly. No? We got no love? No Espanol love? Even if anybody wants to look it up. No, thanks. Okay, it's all right. It's all right. There's got to be something similar, okay? And again, I don't know what it is. But if somebody even wants to look that up and drop it in. Point just being that word in Italian, I know it in Italian because Italian's my most fluent, it's my second language, but my most fluent foreign language, followed by French, followed by Spanish, followed by a bunch of fake it till you make it, probably followed by German. But those are all fake it, truly fake it till you make it, right? That's just like play around and know enough to have a little fun. Semaphore, that relates to the idea. The problem is that is confusing outside of context. The graphic that you just posted. Okay, it means traffic light. That's the name. That's the word for traffic light. So if somebody, anyway, if you want to give me a little chat love on traffic light in other languages. It has to be Latin-based languages.
So I was just gonna say it's the same in German. Semaphore.
Really?
Yeah.
Oh, boom! Wow. Okay, that's cool. Wow.
It's like exactly the same.
That's awesome. Okay, yeah. If anybody wants to drop any of those others, that'd be great. I mean, seriously, and I'm curious, and I should have looked it up by now in my life. But it's a traffic light, right? So we use the word semaphore. It's also the term that gets used for the flags, right? The flags on ships, right? They call those semaphores, don't they?
Yeah.
Feels like they do, right? But again, it's signaling. But I just like the traffic light metaphor because when you got this word, like as the Germans like to say, semaphore, pronounced with apparently a German accent. I don't even know, right?
Semaphore.
That's how bad I am at German, right? I'm like der Männer schläft. I'm tapped out. That's about as good as my German is.
Der Männer schläft ganz gut.
Yeah, and I did understand that because I already said the first three words. No, anyway, I'm just saying, it's a traffic light, right? Because what's a traffic light do? There's an intersection, and everybody can't, there's these parts of the intersection that are multi-purpose, right? If you go make your left turn, that's why left turns are more dangerous than right turns, because the left turn crosses more spaces that are shared by others, right? If you got somebody barreling straight at you and you make a right turn, you're safe. But if you make a left turn, you go right into the path, right? We sometimes call that a critical section in operating systems. The semaphore is the traffic light that just goes, okay, stop, right? And then when you got green light, it is a semaforo. So exactly the same, Jacob. Thank you.
I just had to make a qualifying statement to mine too. It's mostly only used in Swiss German and Austrian dialect.
Okay, fair enough. Cool.
Otherwise, it's just called Signal, like a
Signal, right. Okay, that's awesome. And if anybody wants to rock some Portuguese, in my mind, Portuguese, I'd like to just offend all Brazilians. And I only really have exposure to Brazilian Portuguese. Never been to Portugal, but I've been to Brazil a few times. To me, Portuguese is just, you put like a bunch of marbles in your mouth, then you get drunk and you speak Spanish. That's my perception. It's probably an unfair generalization. Or maybe you're a French person. Ooh, you're a French person who puts marbles in their mouth, gets drunk, and speaks Spanish. Boom, Portuguese. I think I'm there. Okay. That's not overly offensive, is it, to the Brazilians? Okay, I do you know how to pronounce that? Anyway, we've beaten that one to death. Okay, we need a semaphore to say, stop, Dr. K. We got the idea. Okay.
Apparently it's pronounced semaforo.
Semaforo. Okay, that's awesome. Thank you. Yeah, but you got the idea, right? It's the same thing. Now, I want to introduce you to an idea, and the interesting thing, there's a way of. Okay, I'm going to introduce you to the concept, and then the actual the practical application of this concept is going to be a little bit weak, and frankly, I'm sort of like okay with that. Okay, I'm okay with the concept being a little bit weak, just because it's a lot of effort to sort of connect it in to assembly language and the LC3 and whatever. But I do want you to understand the concept. Again, this is a little bit of like it relates, but it's a little bit of an introduction to an idea that is going to be all over your butt for the rest of computer science history. This is anytime you're touching data communication, grabbing data, operating system stuff, and the truth is, it's a model, it's a pattern, if you will, that just persists no matter what you're building. Okay. The idea here, so this is kind of like your first, there is like, exam questions about interrupt-driven versus polling. But an interrupt-driven approach to anything essentially just says, look, set an alarm, right? I set an alarm on my phone, and I just set a timer, right, for, some time out in the future. Okay, and then I'm done, right? I set the timer, and I just kind of go back to what I was doing. Da-da-da. Don't worry about it. I'm not burning. The key is I'm not burning any cycles on the fact that I got to do something in a little while or whatever, right? I just wait. You don't usually sit there and watch the microwave cook your popcorn. It'll go beep, beep, something will happen. You know what I mean? But otherwise, you have to, the alternative, okay, oh, there it goes, right? That's an interrupt. I was literally just interrupted by my own little alarm clock on my phone, okay? That's an interrupt. Now, another approach, so that was the interrupt. I set a little timer, and then it interrupted me. What's the alternative? I can sit here and just watch until it gets to 30 seconds. And what am I really doing? I'm going, yeah, are we there yet? No. Yet? No. Really, I'm doing that myself in my brain, right? Am I not? I'm looking at that going 15, 16, and all the while I'm saying to myself, 19 is not there yet. 21 is not there yet. 22 is there, 23, 4, we're getting closer. Get ready, 6, 7, 8, 9. Oh, okay, yeah, yes, it's been 30 seconds. Okay, that was polling. And setting the alarm was interrupt driven. Okay, now again, if I ask you, tell me the difference, don't just say an alarm is interrupt and a stopwatch is polling. Give me your words. If you said to somebody, you grab a random stranger on the street, or your little brother, your little sister, somebody, right, that's not a CS person, they're like, I was reading this document about computer science and operating systems, and it used the term interrupt driven. And you said Yeah, that's an alarm clock. Do they now know what in that crap you're talking about? You've laid down an example, right? Something analogous, but you got to give me some words around it, right? Why is it like? Because, right? Did I have someone drop in a comment?
So what you're saying is, from what I understand, polling is like watching time go until it reaches a certain destination, and interrupt driven is when you set an alarm for that's a specific time later on, and you just go about your day and do whatever, and then when that alarm goes off, that's when you're interrupted, right?
That's right. That's right.
Okay.
Having set up the interrupt, I then don't worry about it, and it comes to me to tell me, right?
Right.
So
Instead of you going to it and waiting for it. Right.
that's right. That's right. And so the other classic is the classic polling is you're going somewhere, and you're all way younger than me. So for me, it would be like my kids or grandkids. For you, it would be you, like not long ago, or your little siblings. And it's like, are we there? Are we there yet? Are we there yet? Are we there yet? Right? Wasn't there a Simpsons episode, where they're just like, are we there yet? No. Are we there yet? No. And they're like, boom, 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 boom. Okay, that's
I
polling.
think that was the movie when they were going to Alaska.
Oh, was that the Simpsons? Oh, they're okay. I never saw it. Weird. The Simpsons movie, right? Right. That's the exaggerated. Yeah. Hang on, Morgan. I gotta. Yeah. Okay. Okay. Yeah. No one's saying it. No one's saying it in the GIF. All right. Yeah, but so if you're saying, "Are we there yet? Are we there yet?" Oh wait. Okay. Is the movie called "Are We There Yet"?
Yeah, that was the
Oh my
title.
gosh. Okay, that's awesome. Clearly, I didn't see that one either. Right. Interrupt driven equivalent of that is your kids all fall asleep, or your buddy or your roommate, right, or your significant other, whatever, falls asleep, and then you pull on in, and you're just like, hey, we're there, right? That's interrupt driven. Both are trips. Both are helping somebody to know if we're there, but that's interrupt versus polling. It turns out that there are pros and cons to doing this inside an operating system down in the core, okay, and with data communication, whatever. If you are going now, by the way, there is a crap ton of kind of technical detail that I'm not going into. I'll give you some hints as kind of a teaser, but it's just when you get to operating systems, this is coming back hardcore when you get to OS. But with polling, what you wind up having to do is like sit and watch. Like, remember the ready bit, right? And when you do a get C, is that the one? Why do I blank on that? Probably because I always look it up and because it's okay, it's open book. But if I'm trying to do a get C to read a character, right? And you don't press the dang character, what's the code do? I'm going to show you. The code just goes, are you a 1 yet? No. Are you a 1 yet? No. Are you a 1 yet? No. And then suddenly I press a character. Are you a 1 yet? Yes. Great. Give me the character. Now I'm going to do what I do. And it goes, and you call get C again, and it goes back to that. I'm going to show you in the code. In the LC3, the built-in code in the LC3. Okay? So that is polling mode. That is really, in a multitasking system, that's pretty time intensive. You know what I mean? To have your whole computer just be going, now, right? It burning a lot of time for nothing. So typically with I/O in real systems, there is some kind of an interrupt-driven approach. For example, I might set up a routine and I register that routine. And by routine, I mean a little chunk of code, typically written in assembly, okay, or something very low level like C. But I've got this routine and I call it an interrupt service routine. And I set that thing up that basically says to the operating system, if somebody presses a key, would you call that routine? make that routine come alive. Then the routine gets awakened. We pause everybody else in a multitasking system. Pause everybody. That little routine comes alive because it got nudged or punched and goes, oh, there's a character. I grab the character, put it in the queue, and then just and stop and go away again, end. And then the operating system just returns control back to, your regularly scheduled program, which is already in progress, right? And then if they press another key, everything stops and that interrupt service routine runs again. Okay? That's a classic sort of interrupt-based approach. And it stops some routine from just sitting there spinning. There's an interesting hybrid. I might be getting ahead on the slides, but there's an interesting hybrid where I'm going to just sit and spin, but it's such a waste to the system that I'll actually set a little timer for a second or a tenth of a second or, 100 milliseconds and literally go to sleep. And that gives the operating system permission to kind of ignore you and put you over here while other stuff can run. And then it's it's time to run that other, bring that guy back. And then, check the clock. Oh, he's still asleep. Put him back. You know what I mean? And that way you're not sitting there just burning the clock, burning the cycles, in the CPU. Does that kind of make sense? That's more of the lower level example of interrupt driven versus polling. Again, when it's exam time, use your words, explain the ideas to me, explain the concepts to me. Okay? And I have a feeling I have slides. No, I don't. Okay. I have a feeling I'm a genius. Who needs to put slides into this? Okay, so let's talk about specifically the keyboard, and then we're going to drop into the other thing. And by the way, I know we're running we might get through it, but we're running a little bit late on time, and it's okay. I'm just going to go until we finish this section. If you've got to get out of here at 2:15, that's okay. You know where to find the YouTube video, but I'm just going to go till this lecture's done, so that we're coming into next week with trap instructions and the stack, which are each just one class period to get through. Okay. So here's the idea. To get input from the keyboard, we have these things, and again, I'm never going to, play weird alphabet soup games with you. I'm not going to be like KB, there are some things where even when I talk about the MAR and MDR in the exam, I say memory address register. These acronyms are going to be different in different systems, so I don't care if you remember this acronym. But you do need to get the idea that there is a status, for the keyboard, there's a status register and there's a data register. And this is memory mapped I/O still. Okay, remember memory maps? This is memory mapped I/O. The idea here is that the status register looks like this. It's in a certain location. FE00 is the location in memory in the LC3 that is memory mapped to this register. And this register has only one bit that we care about, which is, the high order bit, aka bit 15, aka the sign bit, if you want to look at it that way. And this 0 through 14, don't care, we ignore. We don't care. Okay? This is not an actual spot in memory. This is a special register that's over in the memory stuff. So when I say, hey, I want to read the value in FE00, the MAR doesn't go, oh yeah, let me go look that up for you over here in main memory. No, it goes over to the keyboard stuff and it goes, hey, I got a guy who wants FE00. Like, yeah, I got to tell him it's 1. Okay, and I return that. And I put this value into the MDR, and that's what comes back. So I do have to go out on the bus, but I'm not going into main memory, okay? And then I'm free to read this keyboard data register, which, by the way, is in location FE02 is the location of this in memory, right? It's a memory map again. It's not actually memory, but it's a memory map. And in this case, because with the LC3 we only use 8-bit ASCII, we only care about these lower 8 bits. This up here, 8 through 15, don't care. If there's stuff there, well, there won't be. But, I mean, we don't care. We don't look at it. And we treat this as an ASCII value. We assume that's the social contract. Understand that there are other systems, right? The original IBM PC did not return ASCII values. It returned scan codes, which basically were just a different number that would say, yeah, that one key, somebody pressed it. That was one scan code. Oh, they released it. That was another scan code, right? And then I could map that into what was the key. It allowed me to do multi-language, keyboards. It allows you to map your keyboard into other things that are not like, what you expect from a regular ASCII perspective. And I'm going to go back. Okay. So here's what happens. Sorry, every time I bump my keyboard, it like bumps the slides. So here's what happens. Every time a key is struck, this is the LC3. When a key is struck on the keyboard, the ASCII value is loaded into that location, and that bit is set on the status register. Okay? That is when you strike the key, which creates the ASCII value in that register. After you read it, then it sets that last bit of the status register to 0. It clears it. Okay? I just realized it's a little bit ambiguous to say set to 0. Set is a term that gets ambiguously used in this field. I need to set that value to either 0 or 1. People will say that. Or they'll say that value is set as opposed to cleared, and that does mean 1. So I just realized that it's a little bit confusing, because I think it's not confusing. It's not confusing if you already know it. It might be confusing when you're trying to learn it, but that's the nature of like teaching and pedagogy. Okay. So I'll try to tweak these. After I read the value, I clear that bit. It becomes 0. And then that allows the LC3 to read the keyboard and put another character in to the data register. Okay. Now, if that status register is 0, right? And I go ahead and I read the data register, any guesses what I'm going to get? What say you, my friends? What are your guesses? There aren't a lot of options.
Did you say when the status register is 0?
Yep. Status register is cleared. It's 0. It's like that's telling me there's not a new character, right? There wasn't a key press. But I go ahead and read the data register anyway because I'm stubborn. What am I gonna see?
Would it have what was previously put in there?
Yep, that's it. It's just whatever was left over. Okay. And one of the things, there was a comment from somebody, I can't remember who, but it had to do with the slightly confusing use of the term move, like move a value. In computer science and in, kind of hardware assembly, if I say, okay, that value comes into the register, move it into, this other thing, there is a kind of a natural metaphor of life that says if I take this USB drive and I move it, it in fact is no longer over there, but it's now over here. That's kind of traditional. That's a traditional move in English, right? In hardware and down at that level, we use, in fact, in the original x86 assembly language, the instruction that you used to like copy a value from one register to the other register was called move, M-O-V. That was the instruction, move. And what did it do? It copied, essentially. It took whatever was here and it put it in here. But now what's back there? Well, whatever it was. That's the principle of kind of hardware, low-level software. When you take something and you conceptually move it, it's another entire thing. Like, well, what's left behind? Well, whatever it was, right? in fact, I can get more and more into it, but we won't. But I hope that makes sense. So if I move that value out of that register and take it somewhere else, there's still a copy of it left in there, just, you know. And that is called a move. That is called moving it. So that is a little confusing because otherwise it's like, look, when I pick up this USB drive and move it from over here to over here, I didn't have to do anything. I didn't have to go back over there and scrub its aura off my desk. You know what I mean? I didn't have to do anything. It was inherent because it only exists in one place at one time. Anytime I make a copy of a bit, move the bits are actually moving. They're leaving copies of themselves everywhere they go. You know what I mean? Until it is deliberately overwritten and or, you know, set to zeros or cleared or whatever. So, in fact, you'll just see what it was before. Okay. So David asked the question, is there a reason to do polling over interrupt? Yeah, there are certain situations where there's like literally nothing else to do. But also a lot of times modified polling is used, right? Like check something. If it's not ready, set a timer, go to sleep, wake back up, which is an interrupt to wake me up, check again, right? And that's polling, but it's not like absurd polling, like, are we there yet? Are we there yet? Are we there? This is like, are we there yet? No, okay, I'll take a nap. I wake up, and then you're like, are we there yet? No, and then you go back to sleep. I don't know. That's my answer, David. Best I got for right now. Okay, I'm not going to show you this code because I'm just going to go there. But I am going to show you this, and then, yeah. We're going to go over to the LC3 simulator. But this guy here is just showing you that over here, okay, what am I trying to do? You remember these are friends. That's the bus. There's the MAR, right? And that address comes in like FE00, which is the status register, isn't it? Either that or the data register, I can't remember. FE00 is the status register. You see how I just did that? I looked it up. Remember RTFM? Yeah. Okay, let's say that the MAR has FE00. Well, there's address control logic, which we really haven't talked about before. And it basically says, well, we might be getting it out of memory, maybe, or, you know, if it's FE00, we're actually going to get it from here. So this is just a multiplexer that just turns on that one and turns the others off. So the address control logic decides like which one is going to give the value that's going to go into the MDR. And the trick is, of course, there is no memory FE00 in this main memory. It doesn't exist in there. Okay? It refers to this right there. FE02 refers to this one. And this address control logic decides, you know, and this just suggests symbolically that there could be a bunch of things coming in. Okay? What typically happens in real hardware is there would be something like, you might call it a serial communications controller. It's very common, right? And then you can have different serial communications controllers and different devices can like plug in, you know, and that's kind of what this is really kind of about. Okay, what I want to do, I'm going hard to the hoop here, and I'm pulling up the simulator, and here we go. That's probably a little hard to see. That's easier to see, but I lose my everythingness. Now I get it back. That's not bad, right? Is that okay? Okay. You can see that okay, right?
Yeah, I can see it.
That's about as big as I can reasonably make it anyway. So even if you can't, I think we're going to have to roll with it. Okay, now, you should all be, at this point, becoming familiar with this simulator. And if you're not, then by golly, you got to get on it, okay? This, by the way, is the console, and in order to type stuff in, you have to highlight, you have to click on it to give this the focus. Now when I type things, they're coming like as if it was a keyboard input into the simulator. Okay? I can also clear the, like, okay, let's say for example, okay, this would be good. I'm just going to go lowercase letter K in honor of myself. Nothing happened, right? Do you see that nothing happened? Actually, let me back up. I'm going to go to FE00 and show you they look just like memory, right? But it's memory mapped IO. It's trickery. It's deception. Okay, FE00. I highlight the console. Now watch what happens. I clear the input buffer, one character. What happens? Come on. Deception is what happens. Come on. Okay. Well, that should have changed on the money. Okay, let's do this a different way. We are talking about the keyboard, right? And we are talking about FE00. Yeah, okay. I do not know why that didn't just run the magic trick that I was hoping for.
It's paused right now. You might need to run it.
I'm sure you're right. I'm sure you're right. And the problem is, yeah, thank you. You're absolutely right. And the problem is when I say run, it's going to start running at 3,000 and it's all a bunch of no-ops. but when I say run, okay, right, it's a bunch of junk, but I at least can see everything that happened after that doesn't matter, right? But no, and thank you for that heads up. You're absolutely right. Because the LC3 wasn't doing its job because we didn't say run, but there were no instructions to run, right? But what you'll notice is, what do you see right here? That's 1 and a bunch of zeros, meaning that there was a key press, the bits on. Over here, what do you see? Hex 6B. Anybody want to look that up and take a gander at what hex 6B might actually be? Okay, and we give you a guess, right? It's going to be lowercase k, right? So they went in there, and all I did was just, pressed on this thing. Okay, let me do this. I'm going to unhalt. I'm going to clear all the registers, and I'm going to clear the input buffer, clear the output. All right, let's go back to, just to make this, just to get it nice and lined. I'm going to put the get C instruction right here, okay? How are we going to do that? Probably the easiest way is to go here to the assemble, say dot orig 3000 and just get C. And then let's just, for grins, go halt. And then for grins, go end, okay? So all we're doing, that worked, load into the simulator, okay? What you see is, you should recognize this as trap, right? That's all, the F is the first one, that's 1111, that's the trap instruction. And then it's 20, which is the get C, okay? That's all we're going to do. So all we're going to do is just drop into the get C code. Because what happens is, when you do, we haven't talked about how traps work, really, that's next time. But what you need to understand is that when I say, okay, first of all, when I go into this routine, I can do it this way. If I say step, then that means I execute the next instruction entering a subroutine if necessary. Meaning, if there's a subroutine, I follow it in. I go into the subroutine as I trace. When I use next, I fully execute the next instruction even if it's a subroutine. Like I do everything I let it run, and then I move to the next one. You get the difference, right? What we're going to do is we're going to step. Okay? Now, as soon as that happens, what you're going to see here is the code for get C. Okay? This is the code right here. This is it. That's the whole thing about how to get code from the console. Now, one other thing that I want to just show you. I'm going to go back to way at the beginning. Notice right there. Notice that address. We talked about this, so this is not new. But at address 20 in memory, 0020, at that address is this value 0400. This is the vector table for the trap instructions. These are the addresses for the code in the LC3 memory for the trap instructions. So trap 21 goes to 430. Trap 22 goes to 450. Trap 23 goes to 480. Okay? So it goes to 0400. So therefore, if we just go to 0400, this is the trap code. Okay? That's repeat. Right. And so, yeah, and David, yes, it is paused. Exactly. This is the beauty, right? I'm like, okay, stop. We're stepping, right? This is called a debugger. I'm debugging because I can walk through. So what I can now do, notice I've got still step or next, and none of these are subroutines, you know? By the way, the in, is it in? Actually calls get C, but we're just doing a single character. So what I'm going to do, I'm going to, and if you guys wouldn't mind, humoring me with a little bit of either audio or chat, your ideas about why this is happening. If you can be engaged like that, it's helping your learning. But the first thing I do is I store R7 into 408. I put it right here. Why would I do that? Anybody real quick? Yeah, go. Is that a hot mic or somebody volunteering? Mike.
I'm good.
I didn't mean to be a pun on hot mic, but it was a double mic. Yeah.
No.
What's that?
Sorry. I think I might know.
Yeah, go Tyler.
Isn't R7 where the address to jump back to is stored?
That's right.
Memory?
Anytime you do a JSR or a JSRR or a trap, they're all kind of subroutine calls. The program counter gets put into R7. By the way, let's go look in R7. What is it? That is the incremented program counter, right? We were at instruction 3000, and now the program counter was incremented, 3001, and when we made the trap call, that value got put into R7 per social contract. That's how we did it. Okay, so we don't know whether we're going to fiddle with R7. We probably won't. But as a matter of good, safe programming, we just store it away. So this 408 with just nothing in it, it's all good, That's just sitting there. So I take R7. So let's do this one. I do next. Okay, notice that in 408 is 3001, the value from R7. Now what about this over here? Store blah, blah, blah. That is just because the LC3 simulator wants to try to look at that and treat it like an instruction. You ignore that. You can ignore that because you're like, come on, LC3, you're drunk. No, it's not an instruction. You don't need to tell me that if that were an instruction, this is what it would look like, because it's not. Okay, it's drunk and confused about the social contract. Okay, next thing I do, I load indirect. Ooh, load indirect. The crazy, creepy instruction that nobody could figure out. Like, not nobody, but you know what I mean? It's like, wait, indirect? I go to the thing, I find a treasure map, whatever. This is it in practice, okay? So here's what we do. We do a load indirect, and we go to location 0406, which is right here, which has previously been filled with the value FE00. Okay, remember FE00? That is the keyboard status register. It's over there somewhere. Now, if I had said load, then into R0 would have come the value FE00, but that's not. This is like a jump table. This is a pointer. Okay? So when I say load indirect from 0406, it says go to 0406, look at the value, grab this value, FE00, go there, pull the value from over there and put that into R0. Let's do it. Okay? Now, by the way, it says that there's a character, which I don't even know why. But let's find out. All right. Now what happens is, but you see what happened, right? That was my way. And why would I do this, right? Why not just have this be the status register? Well, you could do that, but this allows me to have this status. Well, for one thing, we're in main memory here. This can't be the status register. I've got to be able to reference a spot somewhere else, Let's see. And if I change that later, I just come in here and change my code, and I'm still good. I can move wherever the status register goes. If we had to change that address for some reason, I would just change this code, and I can still get to it. Okay, now I'm going to check. That's a branch. I'm going to check the 0 and the P. Well, let's check the control codes. It's negative. Wait. Yeah, no, that's right. And negative means we've got something, right? And I still don't understand why we have something. We're going to find out. It might still be a leftover lowercase. I don't know. All right. But if it's either 0 or positive, we just jump back to here. And then what do we do when we jump back? We grab the keyboard status register again. And we're just going, are we there yet? Are we there yet? Are we there yet? Are we there yet? That's all we're doing. Okay? But if it's negative, we have something. So here's what we do. We fell through because it was negative. And now we do another load indirect through 0407. Ooh, what's that? Keyboard data register. That's our data. And again, by social contract with the LC3, we go out to FE02, grab its value, and put that into R0. So we checked, it was okay, there was a character, so we went ahead and grabbed it, we're just overwriting. Boom. That's the small k. Come on, small k. It was still lingering, apparently. I don't know. We pressed another one. But what I don't understand is right here, clear input buffer. It said there were 0 characters. I don't know exactly why. Anyway, and then I just go back to 408. I grab the PC and I just put it back. No, nothing happened with R7. So no blood, no foul. And then I just ret my way back, and here I am right where we started. Okay? Now let me do something here. I want to clear the dang input buffer, clear the output, and I want to do this thing again. I'm resetting everything, and I'm clearing everything, and I just want to go, step. Okay, here we are back in there again. I'm going to save away R7. I'm going to load the status register. Okay, notice this time that it's 0. So there's nothing, right? Now you see what I'm doing? Are we there yet? Are we there yet? Are we there yet? Are we there yet? Somewhere in the middle of it all, I go over here and I press a key. I press the lowercase k. Okay? Are we there yet? Okay, now it now knows about it. And now we fall out. And now we go get the character and put everything back, and we drop in, and there it is, 6b, the lowercase k. That's the code. Kind of cool, right? Let's do one more then. Clear, reset. What's the single character spill out? Is that out? I think it's out. Anybody want to confirm or deny? I know I'm doing what I told you not to do.
I think so.
I'm trying to fly here in real time, but we're gonna find out. We're gonna find that was a pun unintended. We're gonna find out. All right, here we go. What we're gonna do is now check this out. When I say next, it's gonna try to fully execute the get C. So I say next. You're like, whoa, what happened? It's inside get C. It hasn't come back from get C. This is called, sometimes we refer to this as being blocked on I/O. Like I am waiting. I go over here, I press the lowercase k, boom, we come back. See what I mean? Because inside get C, it was going. Finally, I press the keystroke, boom, done, return, I'm back, and notice that 6b is in R0. Now let me do it this way. I'm going to do next instead of step. See the K, right? So when I said next, when I click next, it did the out instruction, which takes whatever's in R0 and spills it to the console. Let's go over there though. Let's clear the output, clear the input buffer, reset all the registers. Okay, here we go. I'm going to go ahead and just do I'm going to step over get C, and I'm going to press the lowercase k again, okay? But I'm going to drop into the out instruction. It's, by the way, did I do it wrong again? I'm a doof. Hang on. Doofus alert. Let me back up. Sorry. I had one job. B, I had a 50-50 chance of getting it right. Okay. I'm going to do a get C, press the lowercase k, and then I'm going to do drop into the out instruction. Okay, here we go. And by the way, 430, if you remember, 430 was where the address was. That's the address that was in location 0021 in memory. When you called trap 21, it went to location 21, grabbed that memory, and did a JSR to that memory right here. It also put
Quick question.
the incremented program counter in R7. Yeah, go.
What's the difference between in and get C? As in, like, calling for input.
Let's take a look real quick on the documentation. Let me blow this up and get it bigger. Yeah, let's take a look. So get C reads a single character. It doesn't echo it to the console, and the ASCII value is copied into R0, right? And the high 8 bits of R0 are cleared. The in prints a prompt to the screen and then reads a single character from the keyboard. The character is echoed to the monitor, and the ASCII code is put into R0. So in does prints this rando prompt. In fact, we can do it. Let's do that next, okay? But we'll come back to it. But it's a good question, and the answer is, we looked that up in the doc about the details. So here's the trap, right? So we store R7 away like normal. We also store R1, and the reason we store R1 is just because we're going to use it. We're going to trash it right there. Okay? And because we're going to trash it, we just save it, whatever it was, we're going to save it away. And then notice here, we're going to load our 7 back. And before that, we're going to load our 1 back. So all this is like save our context, restore the context before we return. Then the whole code is literally just these 3 instructions. And one of them is a branch. So let's do it. So we load our 1 from 4.3 indirect through 4.3.8. 4.3.8 is FE04, which is the console status register. And by the way, I recommend you do this yourself. Get your own simulator going, drop in, do the thing. Watch this if you need to, but do it yourself. That's where the fluency is going to happen. Okay, I load that into R1. I'm now using R1 as like my kind of status thing, right? So, and it's like branch on 0 or positive. So it's like, okay, sorry. On 0 or positive, I think, hang on a second. I'm pretty sure if I remember that when we get over here to the monitor, it's a little bit different. Yeah, when the monitor is done and when the monitor is ready to receive, it sets it to 1. It's a little bit like kind of counterintuitive maybe, you know, because we were already like, if it's cleared, there's no data for me. Here, if it's 1, I can give it data. I don't know. It's a little funky, but in this case, I kind of botched it because I already blew past it. But what we did was we loaded the status register right there into R1. We checked to see that it needed to be negative. If it's not negative, we're going to just loop. There's almost no way to actually show this loop because it's so fast that it pretty much always succeeds. Then we do a store indirect into R0 from 439. So 439 is the FE06 is the keyboard, sorry, the console data register, okay? That's where you put stuff when you want them to appear on the console. So I store indirect whatever's in R0, which is lowercase k, I store that indirect through 439, meaning I put it into this location, FE06. And that causes the system to make the thing show up on the thing. Cool. And then I just keep stepping. I restore R1. Notice R1 gets set back. I restore R7, and I rep my way back, and there I am on halt. Let's do this real quick. And again, we'll go a little bit. We're about done. What I want to do instead of the get C is let's do the in just to show it. We'll do an in instead of a get C. I'm going to got to reset all the registers, just clear everything. Okay, ready? I'm going to do the fully execute the next instruction. Input a character. To me, in is a little dumb. And I can go, okay. And it echoes it and moves on. You know.
I mean, it's a little nice to have a little visualization saying,
Yeah.
"Hey, put a character in here, dummy."
Yeah, exactly.
Instead of the screen just
staring
freezing
at
up
you.
and staring at you, the blank emptiness.
Now, the thing
when
is,
when I was testing it out a little bit ago, I was like, oh, I tried get C first, and I was like, what the heck's going on? And this is before you said it freezes up on you.
yeah. Now let's do one more here real quick. Because the thing about in is that's the message. You're stuck with that message. So another one is you go get C, and then you just spit it out, and then you stop, okay? So, and I'm going to clear the output, and I'm going to clear everything, right? But what I'm going to do this time is I'm just going to run it, okay? and I'm going to go, I pressed K and we were done. Okay? Because what I did now was, again, I'm going to unhalt and let me go back where we were. What I did this time was I read the character, I spit it out, and then stopped. And we call this echoing. That's called echoing the character. Because you can type characters and have them not appear, right? We do it all the time with passwords and other kinds of stuff. But in this case, echoing the character spits the thing back out. Now, when you do your programs, right, the larger program, you're going to need them to enter in a loop, right? You got to be able to be kind of like, they're going to type, JMP, for example. You need to be able, you need to be able to, read the J, echo it out. They read the M, echo it out. Read the P, echo it out. They press enter. Now you're done. You've got to manage that loop yourself, okay, in your program. And then the other cool thing, and I'm going to come back to the last questions that were posted, but the console, where are we at? The output to the monitor, we really just did it. There's the status register. There's the data register. When you write a value, it clears it, and then when it's ready to receive, it sets it. But the ideas are just the same. That's the code that comes basically straight out of the other stuff. And this is exactly the same picture, okay? Other than the fact that the address control logic is identifying the display thing, okay? The only other thing, let me see, is we really just did it. This part of the slides, keyboard with echo, this is really what we just did, but you can look at this code, you can try it, right? Where we're doing this at a really low level, okay? Like we could make our own, this actually comes from the in. I'm pretty sure this actually comes right out of the in code for the in trap routine. And then the only other thing, we did this already. We already talked about I/O, interrupt-driven I/O. Okay, yeah, so that was actually all of those.
I got a quick question about the big program.
Yeah.
Will we need to accept the character inputs will they have to be all capitals?
No.
For the instructions?
No, and
Okay.
that's actually, as a reminder, that particular clarification is in the instructions.
Okay, I have the instructions up. I just wanted to make sure.
Yeah, you have to be, it has to be case insensitive, meaning I don't care. They enter uppercase, lowercase, or any combo.
How does that work with getting that get C and a capital? Does it register that shift as the click or as the keyboard press?
Oh, nope. What it does, in fact, let's just go back and just give you an example. Yeah, we're still good. We're still good right here. Let me just reset and clear everything and clear. And this time, let's just run. And I'm just pressing capital K. What the LC3 does is basically whatever you do,
Increments the ASCII
it
code?
generates the ASCII code, exactly. Now, back in the days when I was writing a keyboard driver for Hewlett-Packard on the original, this is the part where I'm just like proving I'm old, but on the original HP Vectra Classic, HP's first personal computer, I wrote the keyboard driver for OS2 for that machine. And on the x86, on that IBM PC architecture, not x86, but in the architecture, every touch of a key was a scan code. You pressed the shift key down, that was a scan code. Shift key up, scan code. Left shift key down, right shift key down. 2 scan codes. Like every time a key went down, there was a scan code. Every time the key went up, there was a scan code. And if you held it down, it had this thing called type-o-matic rate, where it would do like the repeat. This happens when you like press a key and hold it, and then it's like stops for a second, and then it goes brrr, right? That's called type-o-matic rate, or type-o-matic. There's a pace. There's a point where you realize it's still down, so there's a timer. and then you start spitting it out at a certain speed, right? So all of those were just based upon scan codes. So you understand that I had to write a state machine, right? I mean, this had to be like, am I in the uppercase state? And I could get to the uppercase state with caps lock on, caps lock depressed but not popped up, shift key down, other shift down, right? I mean, there were like, there was a bunch of different scan codes. And the real question, you couldn't make every possible combination if they do this. It was more just like they press the caps lock key down, boom, you're in the uppercase state, right? That's one of the states. And it was a multi-state, kind of a thing. If I'm in this state and it's also an uppercase state, then here's how I treat, right? What's the code that I'm going to generate to kick back the other way, right? So it was that kind of complexity, That's probably a longer answer than you wanted, but welcome to welcome to dealing with an old person. There was a question that David had asked. Let's see. So David asked, because the one is in the high bit, we can check if it's negative. Exactly. That's right. Now, and yes, Stephanie, that is correct, right? 8000. If we, assuming you got the right number of zeros, and it maps into, what is that? It's 16 bits stuff. All right. As long as that is 16 bits and the leftmost bit is 1, boom, negative. Right? So that's why you can branch on negative. Now you could have made any one of those bits the status bit, right? Could have been the rightmost one, could have been somewhere in the middle. The problem is that, you could do it with like it's positive and it's 0 and it never would be negative. So you could have done that, right? You could have done that. That's another way you could have done it. Isn't that true? As long as you clear everything else, it's either going to be positive or 0, and those would be the choices. Instead, it's negative or non-negative, which is why we check for 0 or positive on that branch. Essentially, you're checking for non-negative, aka that bit is cleared. But again, you see some of the patterns, right? That that pop up. Okay, we are very much over time, but we are done. Well, and this is like, okay, this has been in self-justification. This has been a combo of not only getting through the slides and the keyboard, stuff and the display stuff, but also a little bit of a help section on the simulator. You know what I mean? It's been a little bit more involved, like help section, like.
It's kind of a help section on getting the big program started too, accepting input.
Yeah, that's right. Also true. So I'm gonna stop here now. And I feel like Jay and David are encouraging. I don't know. I feel like I need suddenly, for those that are watching this or like tracking the GIFs on Discord. Actually, my hands won't even do that anymore. They're not flexible enough. But no. So here's the deal. We can still do. We're going to do traps. The trap instructions on Tuesday, and the stack on Thursday. Okay, and we will finish them. We will, and I don't know if Zach's still on here or Vlad, but we will still, we'll push back the 11 and 12 modules. We'll push those back. The homework has to be done before you do the exam. That's the only rule on those. Okay? So no real, yeah. Okay. The other thing is, I'm content if anybody wants to do like another help section, maybe on the weekend. I might be occupado from late Friday through Sunday late afternoon, evening, but I could go Sunday night with a kind of a large project help section driven by your questions, where we can be like, okay, you know what I mean? We can do that if that's valuable or interesting. The alternative is we could do that Monday night. Only problem there is just that it's a little more, you know. We could even do it tonight, although that's not enough warning for everybody to free their schedules. I don't know. I'm going to presume that would be helpful to do some help section stuff like that. Could also go Friday during the day.
Monday night would work really well for me.
Depending on what time for me.
Yeah, I can be pretty flex. I mean, Monday is seriously flex in the evening. I can go anytime Monday night. So I don't know who said that last thing. Is that like later is better or
Well,
earlier is better? Or
like later, but thinking about it now, I have a class on Monday at like 2 or 3 o'clock, and that's the last thing I have in the day. So,
okay. Jay confirms weeknights. Any night on the weeknights would be nice. That feels like consensus. Why don't we go? Why don't we go Monday? You know, I can go literally anytime Monday night. So, you know, let's pick a time that doesn't exclude anybody. You know, what do you say? Let's pick one, and then and I'll post an announcement right now to Discord to everybody. You guys get the notes when I send the occasional note out to everybody, right? On Discord, you get that?
maybe.
That does not sound confident.
Notification, but I might not read it.
That's a problem. You got to be, yeah. You have to be like
On the general.
you would always be on the general, probably, yeah.
Yeah, I sometimes I only look at general when it's during class. Maybe
Yeah,
if
no, I get it.
Notifications text channel. That could be good.
What is it?
Maybe if you added a notifications text channel.
Oh no, that's a really great idea. That is a great idea. Like urgent notifications, so you can kind of just keep an
Yeah.
eye on that. Polling
Yeah,
mode.
That way, if I see, like, hey, you got a message on the testing lobby in the notifications.
That's right.
Oh, maybe I should read that one instead of seeing somebody post a GIF on the general channel.
Right, exactly, right. And if it doesn't differentiate posts from me, the very important person in your life with respect to this class, and can't differentiate that between just other noise and other stuff, it really loses the impact.
Yeah.
I've also tried in general to do Canvas, and I don't know if, you know, that's another kind of, what this is, by the way, is an example of where it shows up kind of like an interrupt, but then it sits there asynchronously while you turn it into polling. Because, yeah, you know what I mean? You get the little bling, and you're like, I'm not looking at that. So it's like, I'll poll back later. You know what I mean? That's that interrupt polling thing again. Let's go Monday night. Time of day. 7? That's not too, is that too early or too late for anybody? I know we're a limited group here, but we're trying to put a stake in the sand, and I think we're going to catch the majority of people. And we'll stream it
sounds
to
good to
YouTube.
me.
And we'll stream it to YouTube. So if anybody can't get to it. 7 o'clock? Okay. 7 o'clock, Monday. Okay, that's going to basically be kind of just a help section. I'm going to expect to be heavily in the LC3 simulator, you know, and it has to be driven by your questions. And they have to be intelligent questions. You know, like I don't even know where to start is neither a question, and if it were a question, it's not an intelligent question. You know what I'm trying to say. Okay. All right. Okay, I'm good. Are we done? I think we're done. Rock and roll, baby. You're going to get through this. You're going to get through this. You're going to make it. This semester or next, you will get through this. Hang with me. We will do everything we can to help you. Okay, let's see. Man, this has been long. It's been good. I am going to take us out with some more Mozart. Wait, what happened? Oh, is Zach back? Who's doing that to me? Michael. Okay, we'll go out with Nobody's Gonna Break My Style. No Mozart. No Mozart.
I had to.
Zach's not even here to enjoy this moment. That's the sad part. All right. On that note, I hate that song. You know I do.
Yep.
There are other songs I hate worse, but I'm not going to name them. Not here, not now. All right.